Hello, my name is Dr. JoAnn Ballor. I'm a Marie Curie postdoc at IMDEA Materials Institute, and this is the first episode of UTIFE Science Explained. In this short series, we'll look at how 3D printing is changing the way we design metals, and how our UTIFE project is affecting that process. Sound interesting? Stay tuned! So, what is metal additive manufacturing? In simple terms, it's a way to build up a final metal piece layer by layer. One of the most common techniques for this process is selective laser melting, or SLM. SLM uses a high-powered laser to selectively melt metal powder with very high resolution. This allows us to create complex metal structures, like lattices, that are difficult or impossible to create using traditional manufacturing methods. In conventional manufacturing, we create metal pieces by taking an initial piece of metal and cutting, bending, or machining it into its final shape. This is often limited by the tools that we use or the material itself, and it can generate a lot of waste. Additive manufacturing avoids many of these limitations, but it does come with new challenges. During SLM, the metal heats and cools very rapidly in both the active printing layer and in the material beneath it. These extreme conditions have a significant impact on the final properties of the metal and are the subject of extensive research worldwide. However, conventional alloys, which are optimized for traditional manufacturing processes, are not always well suited to additive manufacturing. Materials with high thermal conductivity or reflectivity can suffer from defects such as pores, lack of fusion, and cracking that significantly deteriorate their performance. So, what kind of materials can actually take advantage of these extreme conditions? In our next episode, we will explore eutectic titanium iron alloys and why they're so promising for additive manufacturing. I'm Dr. JoAnn Ballor from the IMDEA Materials Institute, and this has been UTIFE Science Explained. I'll see you in the next episode.